Hey guys, welcome to another video. Now today we are talking about depreciation, and this idea of depreciation, of the value of something depreciating, you'll find as we go through the video it's actually very similar to compound interest, which we looked at a while back. Now depreciation, we're going to do just one worked example from this particular for this video, and in that we are going to be able to derive a formula for depreciation in the same way we did for compound interest, and then we'll actually go through solving this question as we go. Now first, let's think about what depreciation actually means. Now think about even the word depreciation. Think about how it starts, these first few letters. A word it sounds similar to is depressed, right? So think about a good way I like to remember depreciation is when you're depressed, you feel down. So with depreciation, the value of something is going to go down. So the definition for depreciation is when the value of something goes down. This idea of down is very important because we saw with compound interest the money value went up. With depreciation it is going down. Now a very common real world example of depreciation is buying a car, for example. Cars are very commonly known to depreciate in value very quickly. So say you walk into a dealership and you buy a car for $30,000. As with most cars, a lot of these usually go down in value. So I buy a car tomorrow, for example. In a year, its value is going to be significantly less than this year. And with each year, this value goes down. It depreciates. Now, most commonly with cars, these depreciate by 15%. These depreciate by 15% every year. Now, let's look at this in the context of a question. Now, if I were to ask you a question of, say, by how much would this car depreciate in 1 year? Well, that's pretty easy. We can just say, okay, the original car value, this $30,000, this makes up 100% of the total price. You can see here where our percentages are carrying over. So this makes up 100%. Now, after 1 year, this goes down by 50%. So the price will be 15% less after 1 year. So to find this, well, our price is going to drop. Now we are going to go from 100% of the car's original value, this 30,000, it's going to drop by 15%. So we are going to subtract the percentage that it depreciates, because remember, depreciation is going down. When we subtract, we go down. So after 1 year, 100 minus 15%, the car's value is going to be 85% of what it was the previous year. So to find the cost after 1 year, we are going to take my 30,000 And we want to find 85% of it. So we want to times it by 85% or 0.85 or by 85 over 100. We can do this in any way. Remember, fractions, decimals, percentages, they're all different ways to communicate the same thing. So if we want to find what 85% of 30,000 is, we just want to subtract. Or we want to, well, subtract to get 85, and then we want to multiply because we're finding the percentage of a quantity, 30,000. So we're going to multiply by this percentage. And when we do that, let me get a calculator, multiplying these two together, that gives me 25,500. So this becomes my price after 1 year. Now, if I were to go 2 years, well, my car price at the end of 1 year, that's going to become my input for my second year of depreciation. So I've bought this for 30,000. On the first year I have it, it's worth 30,000. The next year, it's going to drop to 25,500. And then the year after, it is going to drop in 15% of this value. So my value at the start of that second year is 25,500. So that means that after 2 years, my 25,000 is going to drop by another 15%. So my new value is going to be 85% of my original. So we want to find my new price, 25,500, and it's going to drop by another 15%. So we're going to multiply that by 0.85. And what do we get here? Well, when we do that multiplication, we get that it's worth $21,675. Now, we can keep doing this on and on and on, but what if we want to find, for example, the depreciation after 5 years? I mean, we can keep going here and then keep doing what we've been doing. That's great, but it's going to be very time consuming. So let's look and see if we can find some kind of pattern in how these numbers are progressing in the same way we looked at with compound interest. So I'm going to make a little table here. So I have the starting price. I have the depreciation, and I have the end price. Okay, so my original, and let's look at, the amount of, let's add another column to this table. I'm going to add another column, which is years. Okay, so I've drawn up my table, and I'm going to plug in these values and see if I can notice a pattern happening here. So if I start with 30,000, I've depreciated by 0.85. So I've done 30,000, times it by 0.85, and I've ended up with 25,500 after 1 year. After the second year, I've gone, my end price at the end of the first year becomes the start price. So once again, I'm going to multiply it by 0.85. And that gives me 21675 at the end of 2 years. And if we notice here, what I'm getting is my original price. And well, let's just do this one more time. I'm going to take my 21,675. I'm going to multiply it by 0.85. And then I'm going to get, now I'm starting to get some slightly messier numbers. But, okay, here's what I get. So, and at the end of my third year, I have this much, 18,423.75. Nice. So let's just look at what we've been doing each time. We got from 30,000, we multiplied by 0.85 to get me to 25,500. So let's write that in here. So to get from here to here, I multiplied by 0.85. Now, it's important to note as well, the 0.85 was just, let me put it in brackets here, I'll write OP for original price. Or sorry, I'll write 100%, which is my original price, minus my 15%. So my depreciation. My original minus my depreciation. Okay, now if we keep following the arithmetic, to get from 25,500 to this 21,675, I once again multiplied by 0.85. You can see it up here. So I timesed by 0.85 again. Okay. Now to get to my next one, once again, hopefully by now we are seeing a pattern. Getting from 21,675 to this price, I've once again multiplied by 0.85. Multiplied by 0.85. Now instead of doing this all over, instead of doing this all 5 different times, let's actually notice what I'm doing. Well, I'm taking my original price, my very first price, 30,000, and I'm just timesing it by 0.85 a bunch of times. Now, instead of doing this thing of, my starting price is 30,000, then I multiply, then my next price, and I start with that, then I get my next price, I start with that, go on here. Couldn't you say I just got from up here, let's do it in a different color, to down here, I got straight from 30,000 to 18,423.75 by just multiplying by 0.85 3 times. So I can write this as times 0.85 cubed, because this is just a shorthand for saying 0.85 times 0.85 times 0.85. Remember guys, mathematicians are lazy. We are always looking for shortcuts here. So to get to my price, to get to my price after 3 years, I took this and I just timesed it by 0.85 cubed. And I got my answer here. So how do you think we can get to, say, 5 years depreciation? Well, if it keeps going along as we've been doing, all we're just going to do is we're going to multiply by 0.85 another 2 times. Think about it. At the end of 3 years, the one we found here, the number of times we multiplied by 0.85 matched the amount of years. So therefore, we can say that for 5 years depreciation, my $30,000, that could just get multiplied by my 0.85, so my drop, my depreciation each year, to the power of 5. And when I do that, I'm going to get an answer of, 13,311.16. And remember, we always do to 2 decimal places when we're dealing with money, so it gets rounded to the nearest cent. So let's break this down a little bit. First of all, let's do a sense check, right? Because the answer we got is smaller than my original, which we'd expect because we're multiplying by a fraction or a decimal or a percentage. We're multiplying by a portion of a whole. So this thing here, the 0.85, I'm looking for a portion of my whole. I'm looking for less than 100% because the value has dropped. So this is my portion of a whole. So it would make sense if I kept multiplying by a fraction, my value would get smaller and smaller and smaller. So let's actually take what we've done here when we solve this question, and we're going to apply a formula to it, a way that we can understand what's happening, and then once we have that, we can just plug in values as we need. We can find out the depreciation after 20 years, for example, or 30 years, as long as we have a formula that works all the way through. So let's look at what we did. Now, I want a general formula for this. General formula. So this general formula, let's look at what I did. So my depreciation, let's call that D. Or let's just call it D for the depreciated value. That equals, well, let's look at the actual maths that we carried out up here to find the 5 years depreciation. We took the original amount. So from compound interest, you may remember this had a name. We called this the principal, P for principal. And what have we done here? We've multiplied my principal amount, my starting amount, by the drop in value each year. So we took our 100%, our one whole, and we subtracted the depreciation. So the depreciation percentage. So the percentage drop. And the power here was just the amount of years that passed. So that's going to be, let's call that N. N being the number of years. So I'll label all of these things here. So the D is the depreciated value. So the value after the price has dropped. The P stands for the principal. So the starting amount. In this case, it was $30,000, my original price of my car. And the percentage drop, well, that is, in my case here, that was just the 15%. So we said that this had a depreciation value of 15%. And I'm just going to call that, instead of percentage drop, I'm just going to call that R, in a similar way to what we did with compound interest. So this is going to be 1 minus R to the power of N. So my R here, my small r, is the depreciation rate. So the depreciation after each year. And this is expressed as a percentage or percentage drop. Let's write that to keep it consistent. And the N here is the number of years past. So you can see here that the depreciation formula is very similar to our compound interest formula. The only difference is, with our compound interest, our thing was getting bigger, whereas now it's depreciating, it's going down. That's why instead of the plus for my compound interest formula, I have a minus. The value's not going up, it's not adding. Well, adding is characteristic of getting bigger. It is getting smaller. The value of my car, for example, is getting smaller after each year. How do you make something smaller? You subtract. But this is the general formula for depreciation, and we'll apply this to a bunch more practice questions in the next video, in which we will work with both the compound interest as well as the depreciation formula. Thank you so much for watching, and I'll see you in the next video.